So our question is cutting a rod and we have to find the best price. So the question is as follows. So given a rod of length n units and price of all pieces smaller than equal to n, find the most beneficial way of cutting the rod. Okay, so this is our question. So we are given a say a rod of length, any length, its integral length n units, and we know the price of all smaller pieces of the length. Okay, so that means what I have, like I can cut it in size of 1, size of 2, size 3, 4, etc. and I can even leave the rod and I am left with the prices. I am given the prices of all such thing. So let's take the example of length is equal to 4. Okay, so we can cut it in how many ways? So some examples are given, like I can cut it into 4 pieces, 1, 1, 1, 1. So my benefit will be 1 plus 1 plus 1 plus 1, 4. Okay, I can cut it into 2 pieces of size 2. So my price I see here, okay, the length of 2, the price is 5. So I will have 5 plus 5 equal to price will be 10 or benefit will be 10. Similarly, I can cut one piece of length 3 and another piece of length 1. So what will be the price be? 8 for the length 3 and 1 for the length 1. So it is 9. I can cut it in one piece of size 1, another piece of size 1 and the last piece of size 2. So by seeing the table, the price is 1 plus 1 plus 5. So it will be 7. So which is the best way of cutting? So from these cases, it is the cutting it into 2 pieces of size or length 2. Okay, so we see that we can have a cut, we can have multiple cuts. Okay, so that is exponential. It is equal to like finding subsets. Okay, and the number of possible ways will be exponential. So we cannot use this as an efficient solution. So what else? We will use here dynamic programming. And why dynamic programming? First, it should give us some kind of optimal substructure. So we see that even if we cut it into size of 1 and 3, that size 3 can again be cut into 1, 1, 1, 2, 1, something like that. But we will be using the best price that is calculated for length 3. And I can directly give the answer. Okay, so this gives us optimal substructure, and it is a kind of recursive also, that I am cutting larger piece into smaller ones. So that's why we see that it follows kind of paradigm for dynamic programming. So we define a few quantities. Bi, let B of I represent price of optimal cutting of rod of length till I unit. Okay, so it means that is the best price I can get if I have cut the rod till length I. Okay, so B6 means this is the best price I can get for a rod of length 6. Okay, so what we can do now, we can have a recurrence relation. So that is what B of I is equal to max of Vk, where Vk is the price here. So this is Vk, V of 1 is 1, V of 2 is 5, V3 is 8. So which is the price that we get for a length of certain value. So we have B of I is max of Vk plus B of I minus K. So what does this quantity mean? This means that I will cut the rod now into one piece will be of length what K, and other piece will be the best cutting of length I minus K. Okay, so let's see. So I have a rod of length 8, and what I can do, so this 5, 3 represents what? it represents that okay, one thing is vk, I have a length of 5, and for that I will get a benefit of 10 units, and then I have a rod of length 3, so that I have the best price of cutting it into many ways, like, and I can have 1 1 1 1 comma 2, something like that. Okay, so one is that I'm getting by, I am saying that okay, I have a length of vk, a length of k which has a price vk, and other is the best possible cutting of I minus k unit rod. Okay, so this will give us the best solution, and where k varies from 1 to I. So what it means, if I have a rod of length 8, so I can have one piece which is of length 1 and best possible cutting of rest of 7. I can have of length 2, one piece of length 2, and other is the best possible cutting of length 6. I can have a length of 3 and the other is the best possible way of cutting rod of length 5. So this is the thing, and we can vary k from what I can have of 1 unit, 2 unit, and in fact I can go till the rod is of length 8 unit itself, which is k is equal to I itself. So this is the recurrence relation it gives us, and now let's see how can we go from bottom up. So I can calculate first b1, then let's see about 2. So 2 can be of 2 possibilities. Of length 2 I can have a rod of cutting 1 comma 1, or I can take the complete rod of length 2 itself. Similarly for 3, what can happen, I can have 1 1 1, so this is one possibility. I can have of length 1 and rest is of length 2, and again I can cut this in different pieces. I can have 1 1 here also, or I can have a complete piece too. So these are the possible ways, but as I am going from bottom up, so I have already calculated these values. So this algorithm, so I will be calculating b1, b2, b3 till bn, and we see that it will take O of n square time. So let's say that this is our problem. So I have to find b of 8, that is the best way to cut the rod of length 8, where I am given price of all smaller lengths. So what happens here, that we go from bottom up, and b1 is just one way of, it is just size 1, so b1 is 1. b2 is I can cut 1 comma 1 size, or I can have one rod of length 2. So it is v max of v1 plus b1, or directly v2. So this is 1 plus 1, and v2 if I have rod of length 5, so this is 5. So this is maximum best way, so I take b2 is equal to 5. Next we calculate b3. So what can b3 be now? I can take a rod of length 1 and then best of the rest of 2. So it is v1 plus b2, which is 1 plus 5, 6, or I can take a rod of length 2, a piece of length 2 plus best of 1, again this is 6. I can take one complete rod itself of length 3, so this is 8 from the table, and we see that the maximum among them is 8. So I put b3 is equal to 8. Okay, so next let's calculate b4. So it can be, now I can cut, so k can vary from, so if we see this equation, k can vary for b4 from 1 to 4, which means what, I can take, cut a length of 1, cut a length of 2, 3 and 4, and similarly rest part will be, I will find the best that I have calculated till now. Okay, so we know that when I calculate bi, so from bottom up calculation I already know all the b1, b2, b3 till bi minus 1. Okay, so that's the dynamic programming. So b4 is v1 plus b of 3, so 1 plus 8 is 9. v2 means what, I take a length, cut a piece of length 2 and rest is best of 2, so v2 is 5 and b2 is also 5, so it comes out to be 10. So this way we calculate and we find that okay, so 10 is the best possible for 4. We move forward. So b5 is what? So b5 means I have rod of length 5 units So I can now do what? I can take off one length and rest is of length 4, and this I can again divide into best possible case, which I already have calculated. So before, I know I can calculate in many ways. Of length 2 and 2 gives me the best, so I already know that thing, and I can say that okay, best possibility is now I can have V1 one length rod cut of 1 length. I can have V2, which means a cut of 2 units, plus B4, V3 plus B3, V4 plus B2, which means I have a rod of cut of length 4 units, plus B2, which is the best possible way of cutting rod of length 2, V5 plus B1 or V6. So we calculate all these from the table and whatever values we have already calculated, and we see that this is the B6 for this. Which one is the best? 17. So I don't cut at all, so that is the best one. So now we put B6 is equal to 17. Okay, and I have to follow this procedure till B of 8. So now I come B of 7, again I follow the same procedure. It can be V1 plus B6, V2 plus B5, and I do till here, and I find that okay, 18 is the best I can get. So I update B7 is 18. Okay, so now what? I calculate B of 8, which is I can have V1 cut of length 1 plus B7, that is the best way of cutting rod of length 7, which I already know from here. So it is 1 plus 18, 19. I can have a cut of 2, and the best possible way of cutting a rod of length 6. So this is V2, which is 5 plus B6, which I already know that best way of cutting the rod of length 6 is 17. So I add these. Similarly, I do V3 plus B5, V4 plus B4, V5 plus B3, V6 plus B2, V7 plus B1, and V8. So we see that maximum among them is 22. So we choose this value. We now put B of 8 is equal to 22. So we have solved this dynamic programming problem of cutting a rod into pieces so that we get the best price for all of them. And I hope you understand this lecture. Thanks a lot. If you like this video, please subscribe to my YouTube channel and share this video among your friends. Thank you.